Hi, welcome to my channel. This video you are going to see about linear span problems. So let us see what is the definition for linear span. Linear span L of S is equal to A1 alpha 1 plus A2 alpha 2 etc. A1 alpha n, where alpha 1 alpha 2 alpha n is going to be the finite subset of S, and A1 A2 an is an arbitrary finite subset of F. That means all these are vectors and A1 A2 etc. are going to be the scalars in F. Now let us get into the problems. Find the span of subset S 1, 2, 0, 1. These are vectors, vector 1, 2 and 0, 1 of a vector space V2, and prove that the vector 3, 7 belongs to the span of S. Prove also that the vector 3, 7 does not belong to the span of 1, 2 and 2, 4. Let us get into the solution. First we shall find span of S. By definition, L of S is equal to the set of all finite linear combination of S. That is alpha in V2 such that alpha is equal to A1 into 1 2 plus A2 comma 0 1. So we'll be getting A1 and this is going to be 2A1 plus A2 such that A1 A2 belongs to R. So L of S should be in terms of alpha, and this is going to be A1 and 2A1 plus A2. So the vector 3, 7 will belong to L of S if there exist scalars A1 and A2 satisfying the 3, 7 is equal to A1, 2A1 plus A2. That means we need to find out a scalars A1 and A2 satisfying the vector 3, 7. So L3 of 7 is equal to A1, 2A1 plus A2. So A1 is going to be 3 and 2A1 plus A2 is equal to 7. By substituting the value of A1 as 3, we will be getting A2 is equal to 1. So it is possible to express 3, 7 in terms of the scalars A1 and A2, which are going to be 3 and 1. So the vector can be expressed as a linear span of S as 3, 7 is equal to 3 into 1, 2 plus 1 into 0, 1 belongs to L of S. Now completing the second part, we need to prove that 3, 7 does not belong to the span of 1, 2, 2, 4. That means let us take 1, 2, 2, 4, and this can be expressed as A1 plus 2A2 and 2A1 plus 4A2, because alpha is equal to A1 into 1, 2 plus A2 into 2, 4. So this should be A1 plus 2A2 and 2A1 plus 4A2, where A1, A2 belongs to R. The vector 3, 7 will belong to this span if there exists a scalars A1 and A2 for which this condition should be satisfied. That means we need to find out the value for A1 and A2, and that should be the scalars. So 3, 7, A1 plus 2A2 and 2A1 plus 4A2, that is by equating that we will be getting A1 plus 2A2 is equal to 3 and 2A1 plus 4A2 is equal to 7. By solving, we'll be getting that 0 is equal to minus 1, which is absurd because we are not able to find out the constant values for A1 and A2. That means it cannot be expressed in terms of the linear span of the given vectors. Hence, it does not belong to the L of S of 1, 2 and 2, 4. Thank you. Thanks for watching. See you in the next video.